Hey everybody. So this is the first or maybe second, if you count the electrical panel video I did on a series of videos on automation topics. What we're concerned with here is automating various aspects of a brewery at a homebrew level scale. This will be a pretty high level overview. I'm not going to go into a huge amount of implementation detail. What I'm hoping is people that haven't done this before can just kind of glean where to get started. Definitely let me know if there's any particular topic that you'd like to see more detail on. Because of my education, I can go into a lot more detail on the software side than I can the hardware side. I'm a complete noob on the hardware, and I'm learning right along with you. The first question might be, well, why automate? You can make very good beer, of course, with relatively non-sophisticated equipment. So why this push for automation? Well, I think really the primary reason is I'm a techie, I'm a gearhead. My background is in software development, so I just like it. For me, this is a fun thing to do. For other people, I know it would be a special kind of hell. But anybody watching this, I assume if you're still watching even by this point, this is something you're also interested in, mainly just for the sheer fun of it. When I take on a project like these, there are inevitably some failures along the way. But when you finally get it working, you have one of these Tom Hanks fire moments, and these feel really good and kind of make it worth it in of itself. This particular episode will be focused on automating elements of the cold side of a home brewery. Namely, I have two conical fermenters. These are small SS Brewtech 7-gallon unitanks. And what I started out with for automation was these guys. This is what SS Brewtech provides as an option on their conicals. And it works well enough, but it's a little clunky. One of the things I never liked about it is this tri-clamp fitting goes right on the front of the fermenter, and then there's a temperature probe hanging off the back of this guy that you kind of shove down into the thermal well that the tri-clamp wraps around. And so you have this box sticking out off the top of your fermenter, and then if you have both the pump and the heater, you have at least 3 wires coming off of this thing all the time. You've got the wire that's feeding the AC in, and then you've got on the left-hand side there another 2 ports for both a wire for the pump and a wire for the heater. And so at this point, you have all this stuff hanging off of your conical, and if you have 2 or 3 of them, that starts to become just a big, ugly mess of wires, potential trip hazards. Here's another picture of both of the units. And, they each have their own independent AC adapter that requires its own outlet. You got to worry about keeping these things off the floor and away from spills. Really, these just kind of add up to a big mess, especially once you have multiple of these guys. Another thing I didn't like about these is the user control just isn't very good. So, let's say you're currently fermenting at 68 degrees, and that's your set point. Well, then you want a cold crash, then you have to manually hit the set button, and in increments of, depending on how the unit's configured, either 0.5 degrees or 0.1 degrees, you have to continuously click the down arrow down until you get down to 40 degrees, which is kind of a huge pain. And also, these are dumb devices in the sense that they're not internet connected in any way. There's no Wi-Fi built into these. The only interface to them is what you see right there in front of you. Okay, so how do we improve upon that? Well, let me show you with what I ended up with, and then we'll go into some detail. So here are my two conicals out in front, and you can see the near the top of the image, you have the on both sides, both the left and right sides, you have the thermal wells, and then you have one-wire temperature probes going into the thermal wells. But that's the only wire that I now have to have running into the front of the fermenter. And so these two wires are feeding into that control panel behind both of the unitanks. For those that aren't familiar with these unitanks, the heater is just a cone that fits at the bottom of each unitank, and it's a relatively low-powered DC heater, consumes about 8 amps, and it's under the neoprene, so you can't actually see it, but it's just something that wraps around the bottom of the cone there. And then the pump for each unitank is sitting in a glycol chiller, which is out of frame. But when the pump kicks on, it just runs cold glycol through coils that are on the inside of each unitank to cool them off. Here's the inside of the control panel, and we'll go into much more detail in just a moment. But this effectively replaces both of those SS BrewTech controllers that I showed at the beginning. So I no longer need those controllers. I no longer need the power supply for those controllers. This is one single unit that plugs into one single outlet and can drive both the pumps, both the heaters, and both of the temperature probes. Then finally, instead of using just a dumb interface to set the temperatures for the conicals, we have the Brew Control interface, and this connects to the aforementioned control panel wirelessly. And this is software that can run on any Windows machine. I just have mine running on a Windows Surface device, and it's mounted to the wall in my brewery. It's a pretty small panel, but I can remote into this from, say, my office desktop and have a much better display and a real keyboard for writing the control scripts and such for it. Okay, looking at the panel, let me first direct your attention to this area. So we have our AC in. The cord coming in here is plugged into a standard 120 volt electrical outlet. So we have, I think it's a 15 amp outlet. But we have our AC coming in here. And then what it's connecting to is you've got what looks like a blue wire there, because it's the same color as my chroma key, so green is being colored blue. The green ground wire is running to a ground bar, and then black is hot. Black is running to the top row on the terminal block there, and then neutral white is running to the bottom row on that terminal block. So then off of that terminal block, we have two hots, two neutrals, and then from the ground bar below it, we're pulling two grounds. And these are the AC in to our two power supplies here. So these are 2.6 amps in. They provide 12 volts and 10 amps each out DC. So these convert the AC input into a DC output. Now, we need two of them because we're powering two heaters that can draw 8 amps each. So these have 10 amps each max. So the way this is wired up is one of these is wired to each heating element. And we'll get into that exact wiring in a moment. So let me clear these highlights. So the next bit we'll look at is this guy. So from here we're drawing off just one of the power supplies. And we're going into another terminal block that splits this out into a couple different lines. So let's take these lines one by one. One of them is running to the electromechanical relay down here to control one of the pumps. Let's call it pump 1 for now. Another one is also running to the electromechanical relay to control one heater. Let's call that heater 1. And then the third that's coming out of here is actually providing power to one side of this little breakout board down here. And this guy is doing a couple things. The main purpose of the breakout board here is we have a voltage regulator here, you can see with the blue heat sink on it. And that's taking our 12-volt input and converting it to a 5-volt output. And that 5-volt output is coming over here to the microcontroller to actually power the microcontroller itself. Now we're powering everything I just mentioned off of one of the power supplies because we can. So the heater is only going to draw a maximum of 8 amps, and then the pump they're very small DC pumps. It's not going to draw much more than an amp, if that. And then the microcontroller itself is very low amperage, so we'll easily remain within the 10 amp limit of one of the power supplies. Now for the second pump and the second heater, we come off of the other power supply. And for this, we don't even use a terminal block because these power supplies have kind of a mini terminal block built into the top of them, which unfortunately is slightly out of frame. But we can actually draw 2 circuits off the top of this power supply. And so again, these 2 guys are running down here to the electromechanical relay. And one thing I forgot to point out is we also have these guys right here. These are 2 terminal bars that I'm just using for negative DC. And so we have 1 per power supply. So this guy here is for the power supply on the left, and this guy here is for the power supply on the right. And we just run all our negatives back to those and then back up to the negative on the power supply. And then finally, coming off of our electromechanical relay, we have the individual ports for the pumps and the heaters. So these 2 guys down here is pump 1 and pump 2, and then we have heater 1 and heater 2 up here. I think the only component I haven't covered yet are the OneWire sensors, and they are right here. And they are simply powered directly off of the 3.3 volt pin coming off of the microcontroller over here. And that's just running to this breakout board, powering the OneWire temperature sensors, and then the data for these sensors is running back to the board here. This is also where I've had one issue with this panel. So every once in a while, the OneWire sensors will just kind of drop. They'll get a bad signal, they'll report bad data, and then they'll just drop out, like the system has just lost track of them. And I think what's going on there is I made a mistake on the size of pull-up resistor to use for the OneWire sensors. It's just an implementation detail where I should have used probably around a 4.7 ohm resistor, and I think I threw like a 1 point something in there. Um, I'm very new to this, so uh, I think that's the issue, and I need to pull that resistor out, replace it with a slightly larger one, and I think that should probably resolve the issue. Um, for the time being, I've managed to work around it in software. It's actually possible with Brew Control to send a signal to the microcontroller to tell it to reset the OneWire bus when it gets a bad reading. And so far, that has been a workaround that's worked just fine. But I do need to get around to fixing the actual hardware eventually. Let's talk about the electromechanical relays a bit. This is a component where the purpose is to switch on and off devices. It is not intended to rapidly cycle. So this type of relay, it might have a life cycle of, say, 10,000 to 30,000 cycles or so before it starts to fail. So really, it should only turn on and off occasionally. So it's good for controlling pumps that turn off a few times a day, and heaters that turn on and off, several times a day. So the application's pretty good for this purpose. And I guess I should also point out we're talking about DC, relatively low-powered DC heaters here. This is completely a 12-volt system. The heaters are 12-volt, 8-amp heaters. So, these aren't things that you would be able to run an actual mash on. But they're appropriate for, say, gradually raising the temperature of a fermenter, which is what they're being used for here. Okay, let's take a look at the software perspective of all this. So this is how we actually control all the elements that we've hooked together in our fancy control panel. This is all super configurable. You can put your own images in all of these controls. There are built-in algorithms that you can apply to the controls. Things as simple as switches, buttons, but then also there's built-in hysteresis algorithms for holding temperatures. There's built-in PID control algorithms. So there's a lot you can do with this software. This is called Brew Control, and I'll provide a link in the comments. So you can see I have my 2 unitanks represented here, and this is a screen capture, but it was taken very recently, so this is more or less a live view on an actual running system. So you can see this guy. This is the one I actually have active right now. And so this is currently cold crashing. So I've set a ceiling on the temperature and a floor on the temperature. These are maintained via the scripts that you can see in the lower left-hand corner here. These are also very customizable. You can see a snippet of the scripting code here for the control of Unitank 2, the one we're looking at. Now, on one hand, I could have just used an out-of-the-box hysteresis algorithm, but I wanted to have this notion of a ceiling and a floor that were quite a bit different from each other. During cold crash, I don't care if it gets really cold out in the shed, but I do care if it gets too warm. So I want to knock it down from a ceiling, but I don't necessarily want to maintain exactly 43 to 45 degrees. It's okay if it gets even colder. This is pretty useful for fermentation as well, especially for ales. Certain ale strains you might want to kind of let pre-rise a little bit, but you want to cap them at some temperature. The controls I was using from SS Brewtech, you can't really do this. You dial in a temperature, and it tries to maintain that temperature. I really like having this notion of a ceiling and a floor instead. Over here, we have visual representations for both the pump and the heater. Currently, they're both off, but you can see kind of down here on our graph, we have the temperature, the blue line, starting to slowly creep up because it's about 56 degrees in the room. Once that creeps up enough, that pump will kick on and kick down the temperature. Then there's also a pink line here, and that's coming from the tilt. And what's really nice about this software is with the Brew Control software and firmware, tilt hydrometers work out of the box. You don't have to write a script for them. You can just literally drag a box out, tell it what color your tilt is, and it just works. Yeah, so that's really all there is to it, to the software side of this particular control panel for the cold side of my brewery. Yeah, 2 unit tanks. So you have 2 OneWire temperature probes, 2 pumps, 2 heaters, and I also have 2 tilt hydrometers. And of course, the one for, there's nothing in unit tank 1 right now, so that tilt is just disabled. Another nifty thing about Brew Control is it has a data exchange interface that allows you to grab global variables, values from the software, and then do something else with them, typically import them into some other application. So here's a little Python script I wrote. It runs on the same machine as the Brew Control software, and it grabs the hydrometer readings that Brew Control is picking up, and then it fills out the necessary data structures to send these up to Brewfather. So this way I have the data, both temperature and gravity, that I'm grabbing from the control panel, bringing into Brew Control, and then using this script to migrate them from Brew Control over to Brewfather on the web in real time. Okay, that was a lot of stuff. That actually went longer than I expected, even for quite a high-level overview of all the major components. So I'm glad I didn't go into more detail for this video, but I'm certainly glad to, for future videos, please let me know what you'd like to see more information on. Probably the next video I'm going to do is going to be very similar, but it'll be for the hot side of my brewery. So please stay tuned for that. Click subscribe, and I'll see you next time.